Gabriel, thanks for joining. The Ethereum cat herders are back with another episode of PEEPanEIP, the one and only EIP dedicated series where we are discussing an improvement proposal for Ethereum and understand how it is going to make Ethereum even better. I'm your host Pooja Ranjan, and today we are joined by Gabriel Barras and Patrick Gallagher. Today we are going to get an overview of EIP-1822 Universal Upgradeable Proxy Standards. This is a standard track ERC created in 2019 and is available in draft status. Welcome to the show. Before we dive into the proposal, may we please have a few words about you and your association with Ethereum?
Gabriel, you want to go first?
For sure. So I'm a young developer. As soon as I finished school, I got into Consensus. So I've been working with Ethereum since 2016. Fell in love with blockchain and all the community has bringing up in the Ethereum environment. And currently I'm working at Cortesi, a layer 2 solution. And working with contracts, I felt that there was this emerging pattern of using proxies, and that's where the EIP came from. Bring it up, project.
Hey guys, I'm Patrick Gallagher. I got into Ethereum in 2018. I was working in government, and the ability to do hackathons and win prizes was so enticing that I jumped careers into software development, specifically to work on Ethereum. And it's been a pretty good ride ever since. So now I'm a full stack developer in web and mostly Ethereum. And my calling has really been to developer experience and user experience. And so like the first project I created was One-Click dApp, which is a front-end interface tool. And that was like sort of my first step into web development. And today I'm working on two startups. One is Spendless, which is my own startup for no loss DeFi giving and earning. And then the other one is Superfluid, which is another DeFi application. And so Gabriel and I met actually when we were both working at a blockchain company. And he showed me this crazy proxy thing that he was working on. And I instantly thought that it was pretty amazing and, helped refine it a little bit and write some documentation and communicate it with the world. And now it's actually in use today. And it's pretty amazing that we were even asked to come on and talk about it. So I'm pretty excited to be here.
Thank you so much for your introduction. Let's move on to the overview of proposal. I believe we have a presentation to share. So let's begin with that, and then it will be followed by some question and answers.
Sure. So this is probably going to be a little more easier and low level than some of the other presentations I've seen on here. So really, in order to understand the 1822 proxy, we have to kind of understand proxies in general for Ethereum. So we'll start with telling the story of some ocean-going ships. So we have two ships, and the first one is our first set of contracts. We'll call that ship A.Sol. And so this is our contracts. We've deployed them to mainnet. They're really awesome. They're being used, but there's some caveats. We have limited fuel to our new ships, and we have some crew and equipment on those ships that are very important. And so, a couple months down the road, we say, we ran out of fuel. So what if we deployed a new set of contracts? Let's deploy ship B.Sol. And with this new contract, we added a feature that allows us to upgrade, or that allows us to create fuel using renewable energy so we can power our ship and continue sailing the seas. So that's the kind of the backstory that we're setting the stage for. And the first concept that we have to understand when we're using proxies is the concept of a delegate. So you might have be aware of this term as a person in government who represents you or a group of people in a conference or meeting or in a voting situation. And then the verb is to give or commit powers to another agent or representative. So if we take and combine this idea and sort of push it into the software development world, what we have is we have two sets of contracts. We have a proxy contract and a logic contract, and one is doing the delegating to the other. So instead of the first contract, being responsible for all of its own logic and all of its own storage, it's using a delegate to an external contract, to another contract. And the method here is delegate call. So our first, and we'll talk about that more in a second. So the first contract is a proxy contract. It has a thin layer of code, and it has an expandable amount of storage. So that can grow over time. The logic contract is the one we're delegate calling to, and we're going there to get the code that we want to run. So in that contract, we have a large amount of code and we have a small amount of storage, but really that storage is irrelevant because all we're using in the logic contract is the logic. It's the code there. And we're accessing using that delegate call function.
What does it mean for memory or storage to be expandable? Like from the point of view of a Solidity developer, let's say, is that something that needs to be implemented in the contract?
It does not. It's kind of just to demonstrate the idea that you might start with a small amount of storage and it would grow over time. Yeah, probably don't even need to say expandable because it's kind of a given that storage in a contract is can grow.
Yeah, it's all good.
So this delegate call, right? I encourage you, go to solidity.readthedocs.io, check it out. It's identical to a message call, and that instead of calling an external contract, we've got a couple of caveats. And the first one is that message.sender and message.value do not change their values, and that the code at the target address is executed in the context of the calling contract. So back to the definition of a delegate, we're kind of giving the powers to somebody else. So the target address is the person we're saying, hey, like what code should I run? Give me the code that we need to run. And because the message.value and message.sender aren't changing, we can do that enables us to call it in the context of the original proxy contract. And so it enables you to basically pretend like it's the other contract. I'll show you in the next example. Okay, so the first step is that we are going to deploy our logic contract. That's the one with the big chunk of code that we're using. The second one is that we deploy our proxy contract. And we are going to use that using the construct data from the logic contract, which is basically just like it needs a setup command. It needs construct data to set it up. And then we'll play a little game of who's that Pokemon here. If you can guess who it is in the middle. Yeah, that's Ditto. So the proxy contract is basically pretending to be the logic contract. So all of the code in the logic contract, you can run on the proxy contract because it's using that delegate call again to go out and reach it and bring it in and execute it in the context of the proxy.
So just to be clear, I'm just a regular Ethereum user. I've got my externally owned account. In order to interact with this whole setup, I'll be sending my transaction to the proxy contract, at which point the proxy contract makes a delegate call to the logic contract. and we'll take basically code from the logic contract. It'll look like it's being executed in the proxy contract. And that is basically the whole proxy system, correct?
That's exactly right. Yep.
Excellent.
Yep. So that's why we have Ditto, because it's the Pokemon that can morph into other Pokemons and pretend it's that one.
So the logic contract then has access of both its storage and unallocated storage in the proxy contract?
Yeah, that's a good point. So we kind of don't want to mess with storage on the logic contract. And we'll talk about some caveats and some issues that you can run into later if something happens to the logic contract, right? The proxy contract is simply just getting the code that it should run. Doesn't really care about what storage is at the logic contract, because remember, we're running it in context of the storage for the proxy, not of the logic. So the only context, the only like storage that is available to the proxy is its own storage.
But that's what the main thing I was asking. So the logic contract code, its primary memory storage is the unallocated storage of the proxy contract, since it's running in that context.
Yes.
Would that be the right way to? Okay.
Yes.
Cool, thanks.
Yes.
Okay, so now we'll go back to our story, our ship A and our ship B, and we'll jump out to Remix. But before we do that, just to give a kind of visual of what's going to happen, at the top here we have, our ship A, and we are going to abandon ship from ship A to ship B, right? The one that has this renewable energy upgrade. And that's going to be a new logic contract that we are going to.
That's why you don't want memory down there.
Yeah. So we're going to abandon ship and switch out our logic contract to a new one. And we call this an upgrade. So let me switch over to Remix. So the link to this Remix example is in the description for the video. And it's using the magical gist feature of Remix, which is super cool. So you just click that and you get all the contracts that we're going to use.
Do you mind enlarging the code a little bit, just like Control+ing to zoom in a little?
Yeah, like the whole app or just the code?
The code's really the main thing. Yeah, that's great. Thanks.
Okay, so I'm actually not really gonna dive into the code. We can come back to it if there are questions. For the purposes of the example, we are going to deploy our example contract, and it's going to kind of wrap up all these functions to make it easy for us. So first thing, we can name our ship. What should we name it? Any suggestions?
If you're switching it out, Titanic's probably a good call.
Okay, so we'll start with the Titanic, and we'll launch the Titanic. Okay. So, and if we check, we see that a contract was deployed, and this is the logic for ship A. But we don't really actually want that, because we want to get the contract address. Oh, I think it's the contract address for our proxy. Oh, I know. I call it last deployed ship. Okay, so yeah, it's the same address. All right, so this is our ship that we just deployed, and what we're actually going to do is we're going to load ship A, because that's the first one, and we're going to load it at the address of the proxy. And if we look at the ship, there it is, the Titanic. We have a fuel supply of 3 units, and we have some other functions here. We have the captain, and we can call travel. And so when we call travel once, the transaction processes, and then our fuel is reduced. So now we have 2, and we call it 2 more times. Our fuel is now 0. And if we call it again, oh, no fuel left. So it's time to abandon ship, right? Like this ship does not have any functions that allow me to add more fuel, so we're stuck.
So is that fuel stored down in the logic contract, or I mean,
It's stored in the proxy contract.
In the proxy contract, okay.
Yeah, so the proxy is the interface to that the user would see, that they're interacting with,
got it,
and it
okay.
holds the storage and it holds
Okay.
everything that they need. So if we go back to our example contract, we'll call this upgrade ship function, and that's going to do some things like deploy a new ship, and it's going to upgrade to the logic for ship B.
Oh, so that's down in the initial logic contract, the upgrade command.
Yes.
I was wondering how that was going to be done, but that makes a lot of sense. Okay.
So now there's a new logic contract deployed for ship B. But again, we actually don't want this address. We are going to use the same address that we used earlier, that same proxy address. And we are going to load ship B at the same address, right? Because now we replaced the logic there. Okay, so now we got a bunch more functions. Let's see, is the ship the same? Yep, it's still the Titanic. So maybe we should have renamed it. That's not a good example, but
we're going to patch the holes of the Titanic.
Apparently, yeah. And our fuel supply is still 0. So if we try to travel, we still can't do that, right? But we have this ability to add more fuel. So we can call the refuel function, which captures energy from the sun and puts it into batteries and spins our engine. So we're going to refuel. Now we have 10 fuel, and hooray, we can travel again. And the point being here is that everything at the proxy address, all that storage remained in place. So that's our crew and our cargo that we didn't have to abandon. We could kind of take that with us to the new ship. Or you could say we left it in place and we patched the ship, right? Because we upgraded the logic. But that's sort of the beauty of using the proxy is that, if you were to upgrade a contract before proxies, you would have to kind of transfer over all the storage of one contract to a new one, which could, it's painful and could lead to errors, etc. So back on our example, we had our logic contract, and then we abandoned ship to the new one, which gave us ship B's logic and had that renewable energy upgrade that allows us to refuel. Okay, so now we'll get into kind of the code of how the proxy works. And this is the meat of the 1822 proxy. And this is essentially where we're using inline assembly to store at a specific storage address the value of the logic contract. So we have our proxy, and it has a specific storage slot, and at that storage slot is where we find the address for the logic contract. And so the reason and this takes a little bit of knowledge about how storage works in Solidity, but for the most part, you can think of it just like a normal mapping where you have, a location and then a value. And by choosing the specific slot, we can kind of guarantee a low probability of collision because it's such a random location. And when I say low probability, I mean like very, very low. And what that does is it allows us to keep track of where the logic contract is over time while keeping the same storage, basically, because it's going to always occur at this storage slot. And you can see that right here. I wish I had line numbers. I apologize, but SS store and then 0xC5, etc. And so,
So
what
the 0xC5 here, that's the location inside the, as in that's a point, that's just a memory pointer inside the contract to where you're going to store the address.
Yes, to avoid storage collision.
What makes this such a, what makes a low probability of collision? If this is too low level a question to get into here, I totally understand, but is there something that makes this harder than, say, I know, are there storage slots that are more commonly used? Does Solidity start storage slots from the beginning and increment them up? And this is just so far down that anyone's, okay, got it.
Yes, that is just that. And also, Solidity also have the mappings that is the most likely to have any kind of collision, but still a hash function. And if there is a collision there, then Ethereum is broken, and the encryptions on the internet also.
Yeah, we're all in trouble anyway. We'll have bigger problems.
Yeah, we're in trouble. Yeah.
So part of the standard also is the naming for how to get this storage slot. And so what we're doing is we're just hashing the string uppercase Proxiable. And there's a couple other ways to do this. There's also, you can provide like a specific naming syntax here that you can keep track of. So you could say EIP-1822.v1, right? And hash that, and you generate that storage slot. And what that does is that helps during the upgrade process, which we'll go into next.
So the EIP doesn't specify using this particular memory pointer. It could be a different one also. Is that correct? And it doesn't have to be 0xC5F1 ...
It does not, right? It's up to the implementer.
Okay, got it.
And in fact, the two examples right now of this deployed on mainnet, I think they both use something different. So I think originally, Gabriel, you had hoped that we could standardize that slot, but it ended up not being adopted as much as we thought was going to occur.
We thought, yes. And there is another EIP trying to do the same thing. So it's good to separate these kind of issues.
So once we have the storage slot in place, then that helps us later when we want to perform an upgrade. So here is the second contract that is part of the standard, which is the Proxiable contract. And these don't necessarily need to be separate deployed contracts. They can all be part of the proxy. And I'm sorry, I apologize. This goes in the logic contract that you would deploy. The proxy contract is in your proxy, and that's like what I said. That's that thin layer. There is a tiny bit of logic that always gets executed, and basically, if this was to expand more, if we would see more lines, we would see again. There's another function that's just a fallback that calls delegate call to the logic contract. So that's the thin layer in the proxy. And then in the logic side, that's what's going to be handling the upgrades. And so you could adapt this to your needs, but if you can also just use it out of the box in the standard for Proxiable. And so what Proxiable is it helps you to perform an upgrade without getting into trouble. And so when I say getting into trouble, I mean something like I have ship A and I want to upgrade to ship C, but ship C actually doesn't have the ability to upgrade. So I could get stuck. It could be a dead end, right? And so if I were to upgrade to ship C, I could never, ever upgrade again and I would be lost. Or maybe I have ship A and I upgrade to ship 0 and like 0 has no code at it, right? And so I try to point my proxy at a logic contract that has like no functions at all, then my whole proxy contract is now frozen and I can't do anything. So the way this kind of prevents bad upgrades is by performing a check and essentially calling the new logic contract and checking the same storage slot that's in the current proxy and seeing if it also implements the same storage address. So when we hashed Proxiable and then got the 0x5c, that's like kind of very important that, that's where the storage, or that's where the location of the logic contract is. So if we were to upgrade to something that didn't have that implemented, then we could be in trouble. And so after we perform this check, then we again do the inline assembly where we update at the specific location the new address for the new logic contract. And so this is what we called when we performed our abandoned ship.
Abandoned ship.
Yeah.
So I think there's something that I must have misunderstood before. This storage space, the 0xC5, etc. That's something. Actually, let me ask it like this: what's being stored there in the proxy contract, and what's being stored there in the logic contract?
So that is not being stored in the logic contract. It's basically at all. It's that's why we call Proxiable UUID. It's just a random number that ensures compatibility. And we end up using the same place as what you use to store on the proxy contract for the logic address, because that is already something very random and it's very related to your implementation. So if you were to use a contract, let's say you have several sets of contracts that you wish to have proxy and proxiables like 1822, but they are very different contracts. That will help you ensure that you're never calling with the wrong address, for instance.
Okay. Okay. Fine. I see what there was something I misunderstood before, but yeah, that cleared it up. Okay. Great. Thanks.
I think also could help that I showed the full contract in the slide, but it was limited in room. The Proxiable contract is part of your logic contract, and it has this function that's not actually returning from storage. It's just from this function. It's actually returning the same value.
Right. Yeah. That is, yes, you are correct. That is where I was confused. I thought it was actually returning from the storage as opposed to just returning the pointer.
Okay. So now we'll kind of go back to something that Brent brought up earlier, which is, what's happening with the storage of the logic contract, and what's going to happen if something, goes wrong with that. And so this library lock is sort of a suggestion or a suggested method for addressing this. And it's part of the EIP, not like the core EIP, but if you were going to implement it, here's what you would want to do. And so you can find more information about it. Essentially what a library lock is it does two things. It prevents the logic contract from being called directly, and it also prevents things like initializing it multiple times. And so if you are familiar with the parity wallet hack, that was a situation where many wallets, which were proxy wallets, relied on a single library or logic contract. Those are the same. I'm using them in the same way here. The library contract was manipulated in a way that prevented it from being used properly. And so all of the proxies which depended on it were now defunct and could no longer be used. And so what the library lock here addresses is to prevent something like that from being happening, and preventing you from calling that logic contract out there and modifying its storage, or calling another initializer, or just any kind of funny business, basically. And so hopefully we can keep the logic contract just this static, etched in stone thing that just we can always depend on and we don't have to worry about. And so that's what the library lock solves.
Yeah, just as a little footnote on that, since there were a few different parity issues, you are referring to the DevOps 199. I accidentally killed it. Parity multi-sig hack, right?
Yes.
Yes.
December 2017, if I remember right. I think it was then, just in case anybody's looking it up. But yeah.
Yes.
So how does this stop? I'm taking a look at this. It looks like you have basically a global variable inside the contract called initialized. And it's set to true once you call the initialize function. Shouldn't there still be a little gap of time between the contract being deployed and someone calling the initialize function for the contract to be protected from direct calls?
Little gap of time. Basically, the idea of initialize here is to have that be part of your constructor.
Okay, got it. As in already in the constructor, you're going to set initialize to true, and then the modifier is going to kick on all the functions and only allow delegate calls. Okay, cool.
Yeah, and because the library has no constructor, that can never happen to the library itself.
Oh, yeah, okay. That's, yeah, got it.
That makes sense.
Another caveat just to cover is the storage pattern and specifically the order of storage. Because you're taking the same storage and applying a new logic contract to it, you don't want to get in a situation where the new logic contract thinks that things are in different places, because then you can get into some really bad situations. So the TLDR is never reorder your storage when you're using a proxy contract. Always append new items to storage. And that might feel a little weird, right? Because maybe you're doing some gas optimization and you're like, well, if I put this up here next to the these types of variables, then I can save on gas. Don't do that. You want to avoid that. Because if your new logic contract thinks that things are in different places, right? Because that's possible. If you tell your logic contract, hey, here's the new order of variables, it's going to go look at them and it's going to be in the wrong storage slots. It's not going to find it, and you could definitely like mess up your contract permanently.
I take it that means that you also shouldn't change the data type. Like if someone realized that fuel supply could be a UN8 or something like that, they wouldn't be able to dial that down. I
would say you should be very confident before you do something like that. It's possible you could, I guess.
Yeah, I see. Yeah, it might depend what's there before it. Yeah, got it. Yeah, if nobody ever used,
if fuel supply was 0, I guess then you could cast it to UN8. But if there wasn't a value in there that was larger, then now it's going to be very confused. I don't know what the EVM would do then. Okay, so there are 2 production examples of the proxy. One is the RDAI project, which is a DeFi tool that essentially wraps Compound and redirects the interest to another party. And so this was my implementation of 1822, and I ended up building some tooling for that. It's deployed now. We had it audited. So if you're curious to see like real world examples with value in them, that's where you should go first. And then Superfluid Finance is in testnet, but it will be coming out on mainnet soon. And so that is the latest version of production usage for the OOPS proxy. And again, this is where I said, I think both of these examples actually use different storage slots. So, it's up to the implementer how you want to name your storage slot. And then of course around GitHub, if you just search for EIP-1822, you'll see other people who have implemented it in their own projects. And again, all these links will be in the video description. And then in terms of tooling, there is a command line package that helps you convert your existing contracts to a proxy. Essentially, this grabs all of your storage and puts it into one contract so that you can apply the same patterns and prevent, reordering storage and all that sort of thing. And I think it also adds a library lock. So that was kind of fun. I created that back when we were working on RDI. There's a truffle plugin made by a community member. Of course, there's the gist that you saw in the demo today, and then there's a truffle box as well. So you can get running quickly with truffle box. So if there's no other questions about the presentation itself, we can talk a little bit about, I guess, what's next for the EIP and closing thoughts.
I had a couple of things that maybe I'd try and put in here just before hopping into the EIP process section. One is that I believe you mentioned a few times that the proxy contract should be a thin layer. Let's say that someone knows that there's certain core functionality they don't mind coding directly in the proxy contract, and there's only a few little functions that they want to make upgradable. Would that be, is that undesirable? As in, do we specifically want the proxy contracts to be as lean as possible?
Gabriel?
Yeah, I mean, it's really up to the developer to know what is their needs in the specific situation they are trying to tackle. The idea here is to maximize, really to show to what extent you can really make your code upgradable and abstract all the logic to things that you can upgrade. But it is definitely possible to do, as you said. And actually thinking about real world usage, it is more likely than not that some compromise would happen, like you said, because most contracts today are not upgradable at all or have very little upgradability logic into them as a part of their design, because people want to be sure that they have a contract, that the contract they signed or interacting with will not change suddenly under their feet. And that makes sense in that scenario that you only enable certain functionalities to be upgraded. So yeah, for sure.
Cool. Awesome. Oh, so you were gonna say?
Well, I was just gonna say, it like Gabriel was saying, it kind of opens up a can of worms when you start making certain parts upgradable and other parts are not. If you wanted to do that, though, I would suggest the diamond standard, which I think was an earlier episode on PEEPanEIP. So I think that would be your best bet. But from an implementer standpoint, from a dApp developer standpoint, it's just easier when you can upgrade the whole thing rather than picking and choosing, at least from what we found. So if there was, any kind of bug in some specific function that wasn't upgradable, like you still have, the whole canvas. You don't have any restrictions to what you can upgrade.
You mentioned the diamond standard. That actually was the next thing I was going to ask about, with just from a high level, what the difference between a proxy and a diamond is. Since I think my first question was going to be if you knew about the standard. I see that you do. So from a high level, what is the difference between using a proxy system and using a diamond system?
Go ahead, Patrick.
Yeah, it's the diamond has evolved a lot. So hopefully my thinking is up to date. And in that the diamond standard specifies upgradability on a per function basis. I don't know if that's still correct, but that was my thinking. So you could essentially.
I do believe that it specifies specific functions.
Okay.
I could be wrong also. It's been a while.
Yeah, so I think you can upgrade certain functions, and You know, using any kind of upgradable or proxy, it opens a can of worms for governance, for decision making, for administration. And so really, like, it's up to the group, the developers, to decide, you know, what makes the most sense for our situation. Are we a project where, you know, we only want to say, hey, you know, community, we will only ever touch these functions, we're never going to touch these ones? Or are we a project that's saying, you know, hey, we're in rapid development, we're not really sure which functions we might want to upgrade? So those are situations where you want to decide, you know, do I want a fully upgradable contract like the 1822, or do I want to piecemeal upgrading and do only specific functions? So that's really kind of like a more business and community decision and governance than it is a technical one. Although there are definitely a lot of technical, you know, differences as well.
And you always have the option to, after a few iterations, let's say 1 year, 6 months in, and you're very, very comfortable with what you have right now, just to upgrade to a version that cannot be upgraded anymore. So that's still on the table.
How would that look? A version that couldn't be upgraded? What would need to change?
You need
that
to,
contract?
yeah. So you would need to still implement a Proxiable logic contract like you've been doing through your development, but then remove the function that updates the code.
Yeah. Which means that the upgrade function from the beginning would have to be the last function. Am I correct about that? Because otherwise you'd be removing it from the middle.
I didn't quite got your question.
Oh no. Okay, wait. I think I might have mixed up two concepts right there. I was recalling what you said about not reordering when you have different logic contracts. That's specific arguments though, as opposed to functions, correct?
Yeah.
Yeah. Okay. So that was just me mixing two things up.
Yeah, you could certainly upgrade an 1822 to a diamond, I guess. Like
yeah, definitely.
That's possible. You could even do that.
Interesting.
I mean, it would have an extra layer of proxy, I guess, but it's still, you would be able to do that.
Mm, very interesting.
Or do the opposite as well. You could also get from a diamond and get some functionality into 1822. It really is up to you, yeah.
The world of complex Ethereum proxy networks, yeah.
Yeah.
These are great questions, by the way. Thank you.
Thanks. That is it for me on the technical questions, though. So if you wanted to move on to the EIP process for 1822, I think that would be great.
Okay. So I think the next section is about when and why should EIP-1820 be moved to the next state. So we just submitted a pull request to convert it to review stage. Yay! So yeah, we read the EIP-1, and I think it's up to the developers or the authors to decide when it's ready for review. And Gabriel and I spoke, and we both decided that, you know, we've collected a lot of feedback, and that, you know, we think that we are ready for review.
Yeah, well, I mean, it's already been implemented in some of their projects, as you discussed earlier. So I think review would be the most appropriate state at this point of time to maybe, you know, getting feedbacks from the editor and leave comments on how we keep on processing this proposal to be a standard. I mean, I'm happy that it is already, I mean, there is already a PR to move it to review, but looking at the proposal, and as we discussed today, like these are moving in different projects, and this is like upgradeable from all these standards. My question would be like, how soon do you think it would be ready for last call?
The EIP has been out for quite some time. What Patrick said is really our experience. There are several developers reaching out, trying to understand it. Some discussions on Ethereum magicians. After a lot of conversation, it feels like there's nothing much to it anymore to be discussed. So leaving it for a little bit of time, just since now we have this video coming out soon as well. More people are gonna be aware of it and might engage. So maybe leaving it a month or two to these newcomers to understand and see if they still have something to say. And then moving to last call would be actually something that I see as appropriate for the EIP right now.
Yeah, that sounds good. Just for you to know, like for review, there is no fixed period, but as you said that you would want to keep it open for public to provide any further feedback if they have any, as well as from the editor's end. Just for the last call, it will be there for 2 weeks, but yeah, it's fine to wait for another month or so.
And how long, you said it's been out there for some time, is that a year, 3 years?
2019, I think this proposal was written, right?
Yeah.
Oh, okay, cool, thanks.
2019, and our DAI is now over 1 year old. So 1 year in production with now over 100,000 locked in DAI, which is kind of a lot to me, at least. So no hacks yet, and hopefully none ever. And also Superfluid is about to finish audits hopefully soon. And that will be yet another audit that is for this specific EIP, or at least an implementation of it. So that will be, I think, for me, like another solidifying factor, at least.
Wow, impressive. And you're still in draft, wow.
Well, that's another purpose that we are trying to, solve with this PEEPanEIP, that even if a proposal is good and it is still in the draft status, let it keep moving to the next state and eventually as a standard, so that it should be available, like people should know about it and start implementing in the projects.
Mm-hmm.
This is a very good presentation. I would sincerely like to thank Gabriel and Patrick, you both taking out time and sharing this information. If we receive any further question on this particular proposal, we'll send it your way. It was great talking to you. And thanks to our Cat Herders team for collecting questions and making this session even more knowledgeable. I have thoroughly enjoyed the conversation and hope that it will be helpful for decentralized application developers considering to implement this in their project. We already have a few live examples. For our YouTube viewers, the presentation and the resources shared are available in the description box. If you have any questions that couldn't be answered today, you may leave a comment, or you can ask the author. Their Twitter and GitHub handles are provided in the description section. Do let us know how you like this episode and which EIP would you like to see in the future episodes. Your feedback is important to us, and we'll be able to bring more informative episodes for you. If you have missed a proposal discussion earlier, the recording is available on PEEPanEIP playlist at Ethereum Cat Herders YouTube. If you like today's episode, do hit like, share. Don't forget to subscribe to the Ethereum Cat Herders YouTube channel. Keep sharing your love with Ethereum Cat Herders. This is all of us signing out. Thank you.
Thank you.